Hello guys, hope you are doing well. Today we are going to continue with our lab of FortiGate SD-WAN. We will do the next load balancing algorithm, which is the low cost SLA load balancing algorithm. So first of all, I will create a performance SLA or global DNS reachability. Hmm, Global DNS, I want all the SD-WAN members. SLA target will be 50 ms, 0% packet loss. Latency should be 50 ms, jitter should be also 50 ms. It will take some time. You guys can see. Okay. Now we will go into the rules. I will create a new rule. I will say, okay, so it's address all, destination address also all. Okay, I don't want to specify any kind of protocol number, so I will keep it as any. Okay, so what do you mean by low cost SLA? In low cost SLA, if you are having two links, okay, and I have defined a lower cost over here, say for example 5, and higher cost over here, say for example 10. Okay, and both of the links are satisfying the SLA, say our the reachability towards the global DNS, then all the traffic will go via the link which is having the lowest SLA, which is port 2 in our case, which will be having lower cost. Okay, and if none of one of the link is behaving, like for example, say for example port 2 is not behaving properly, like it is having high quality of like high amount of degradation, then even after having the low cost, the entire traffic will go via the second link which is having the higher cost. Okay, I will give a interface preference over here, say for example WAN 2. Okay, I'll click on OK. Okay, required SLA target, which is our global DNS. Okay, now what I will do, I will go in SD-WAN. Okay, as of now the cost is 0. What I will do, I will give a lower cost for this link and a higher cost for this link. I'll just open up these PCs. Okay, now as of now everything is working fine. Okay, you guys can see the packet loss, there was a minimum packet loss. Okay, not sure why it is there, but now it will be not there. Okay, let me go over here. As of now the SLA is been satisfied. Okay, there is no breach in the SLA. Okay, there is packet loss. Not sure why it is happening. Loss should be not there. Okay. Let me give a ping. Ping 192.168.0.1. Okay, now the packet loss has reduced. Let me check if there is any configuration over here. Okay, there is QoS over here. Okay, okay, that's the reason. Actually, there was QoS configured. That's the reason the link performance was getting degraded. Okay, here it is not there. Okay, now everything will be fine. Okay, great. Uh, Coming back to our point. Okay, we have configured the SD-WAN rules. Okay, what I will do, I have given low cost to the link port 2. Okay, and higher cost to the port 3. By default, all the traffic will go via port 2 only. But before that, we will do some configuration. You guys can see we have configured a service which is named as low cost SLA. Okay, we have given the priority members 1 and 2. And if you see config health check, which is the not here you can see config health check. Here there will be a DNS. Yeah, this is a DNS. I think we have to set members over here. Okay, config members, config health check. Okay, health check, set server, set members, 1 2. Okay, now we are done with the configuration of SD-WAN. Not sure why there is packet loss over here. Let me check if presently we are having any packet loss on port 3. Okay, there is no packet loss now. Packet loss or latency is not there. Okay, we have done this configuration. Okay, for SLA. Now I will show you the configuration. SD-WAN. Okay, you guys can see we have configured a service which is having all members 1 and 2, and we have configured global DNS as well. Okay, yeah. So this is for SLA. Now by default, all the traffic will go via port 2 only. Okay. Before that, we will do a diagnostic test. SD-WAN, you guys can see, and service. Okay. So what do you mean by service? Service is the rule which we have configured over here. Okay. And it is having an ID one. This one. You guys can see. As of now, it has selected the both the members. Okay. Cost 2, cost 5, and cost 10. Now I will see the health check. For example, okay. You guys can see there is 3% packet loss on port 2, because of which the link, even if it is having lower cost, the traffic will go via the port 3. That's the reason it is having the highest sequence number. Okay. So unfortunately, the link via port 2 is having higher packet loss. So even if it is having the lower cost, see, all the traffic will go via 40.1.1.2, because the SLA is not getting satisfied over here. If the SLA would have got satisfied over here, then due to lower cost, the traffic would have went through via the 30.1.1.2. But the SLA is not getting satisfied due to the WAN link issue on this link. Okay, all the traffic is going via this link only. So we will do testing. Okay, we will not blindly form assumptions. What I will do, I will try to in the global DNS. Similarly, over here as well. Oh, sorry. Let's see if the performance SLA is getting satisfied. I'm not sure why there is a packet loss over here. See, both the links is having packet loss. I think there is some configuration issue over here, or there might be issue at my ISP end. Okay, now let's check over here. Okay, what we will do, I will check diagnose system service. Okay, you guys can see now, just because this link is having less packet loss. Okay, okay, okay. See, you guys can see link one is having higher packet loss, which is port 2. Okay, there is some packet loss over here, That's the reason the sequence number of port 3 is higher. The path via port 3 will be preferred. You guys can see there is some packet loss. You can see that the nature is dynamic. Okay, sometimes port 2 link is having packet loss, sometimes port 1 link is having packet loss. Port 3 link, sorry. Now both the links are not having packet loss. Now if you see, the, the traffic via port 2 will be preferred. Okay, because that is having the low cost 5. But if any one of them is misbehaving, if the SL is not getting satisfied, then the traffic, like if the link port to link is misbehaving, then the traffic will automatically get shifted to the link which is having the stabilized, like the SL is getting satisfied on that link. That link will be preferred. You guys can see WAN 1 is having packet loss. If you go in FortiGate, get system session list. See, all the traffic is going via 40 only, which is this link. This one, set port 3. Because this is because they, you guys can see, because the port 2 is having packet loss. So even after having low cost, if it is having packet loss, then also that link will go via the port 3 link will be preferred, because you guys can see it is having 0% packet loss. Latency is also satisfied. Okay. So this is the actual concept. But let me check why here there is packet loss. Ideally, in lab environment, there should be no packet loss. I think this router is misbehaving or something like that. Virtual reassembly, okay. Everything is fine. Load, okay. Fine. Correct. Okay, there might be some issue on the switch side. Okay, I believe. Okay, there is a delay over here. I think I was doing some research and development. That's why this has happened. Ideally, there should be no packet loss. Performance SLA. Let me try to ping. But you guys got the concept, right? What is this lab meant to be? Okay, there might be some issue on the my WAN end. Okay, That's the reason this, what we will do, we can do one thing, okay? I can give a higher cost to this link and lower cost to this link, okay? Then ideally the traffic will go via 40.1.1.2 only, just because it is having low cost link. But you guys got my concept, okay? So what is the agenda behind this video? So it's not about giving a higher cost or low cost, okay? I have given a lower cost to this link 30.1.1.2. Ideally, depending on this load balancing algorithm, which is low cost SLA, all the traffic should go. You guys can also see, okay? Port 3 member is getting selected. Although the SLA on this link is low, sorry, the cost on this link is low. Then also, just because it is not satisfying the SLA, okay? Again, I will show you. It's not satisfying the SLA. There is a packet loss in the WAN end, due to which the path via port 3 is preferred. Okay, so that is the concept. If this link is satisfying the SLA, say for example it is having 0% packet loss, okay, then the traffic will go via the port 2 because it is having the low cost. Now it is not satisfying the SLA, then that is the reason the traffic is going via the 40.1.1.2. You guys can see all the traffic. See, here you cannot see any kind of 30 number, okay, only one is there. That also it is dynamic in nature. So this is what I wanted to explain you guys. So I hope you guys would have liked this video. Stay tuned for the upcoming videos. Thank you.